geoengineering students here, and also I would say aspiring professionals here also. No matter your course of study, if it's geology, geography, environmental science, urban planning, and everything, you're welcome here. You're in the right place. So before we begin, I would like to confirm if we have all installed our QGIS. Just give a thumbs up if you have installed the QGIS. Oh, that's nice. Okay. So today's session is part of the DigGeoNaija University Affiliate Program, DUAP for short. And I would just like to talk briefly about what DUAP stands for. DUAP is DigGeoNaija University Affiliate Program, obviously, and it is an initiative designed to empower students and young professionals across Africa with practical geospatial skills and professional development opportunities. So through DUAP, we've hosted impactful sessions across several universities in Africa, covering everything from GIS and geospatial skills. And participants get hands-on experience and exposure to tools that can sharpen their careers and ideas. So, like I said earlier, that no matter your course of study, there is something here for you and there's something that you are going to gain. So let's move forward. Today's workshop will run for about 2 hours, and it is focused on a super practical goal, which is to learn how to process and visualize DM data using QGIS. And leading us through all this are two amazing tutors, Ms. Oludipe Victoria and Mr. Oseni Ridwan. They'll be walking us step by step through the key tools and demonstrations you'll be seeing today. So you are definitely in good hands. So before we start for today, let's take a moment to talk about the company making all this possible, DigGeoNaija. I'm sure you might be wondering what DigGeoNaija means. So I'm here to tell you about DigGeoNaija. DigGeoNaija is digital heritage innovation in Nigeria, and that is exactly what we do. We're a tech-driven initiative elevating Nigeria's tourism sector through massive experiences and sustainable practices. So what is our mission? Our mission is to enhance accessibility and also conserve Nigeria geosites while promoting sustainable tourism. While our vision is to use cutting-edge immersive technologies and innovations to bring the geoheritage in Nigeria to the world, while also ensuring preservation for future generations. So what exactly do we do at DigGeoNaija? Yeah, some of our products. There we offer virtual tours and digital experiences. We create immersive and interactive 3D tours of geosites, so you can explore them from anywhere in the world. You can be in your house and then explore. Then we have a 3D geosite model. These are high precision models of landscapes and terrains, and it is useful for you. You can whenever you want to do your research work or your project, and I'm sure we have professionals too here also, can also use it for analysis or even for teaching. We have our thematic maps and Excel cards. We designed these learning tools for educators and also explorers. Our Excel cards for our younger explorers also. Digital DEM and GIS map. If you are interested in geospatial analysis, we've got the real tools, the shape files, the reports. We have the kind of stuff that you think you will need, and it's something that you can use for your research work and even for your projects. Sites, artworks, and merchandise. For just the creative side of things, we turn geosite beauty into a wearable or collectible items to spread awareness and also to raise support We have our documentary series. If you have been following us on our social media, on our social media platform, you would have seen what we are doing. So we tell the stories of Nigeria geosites in visual form, and these documentaries, they are not just there, they are informative and they're also inspiring. We tell the story of this landscape through them, and you see the science, you see the culture, and you see the beauty of this geosite, and even places that you don't even know existed. You would see it there. Just catch them on our YouTube channel at DigGeoNaija. And while at it, please subscribe. Then we have Geology storybook and educational tools, and also our training and consultancy. Just like today's workshop, we deliver geospatial training and also data analytics. So if you want to upskill in mapping, in data science, in geospatial skills, this is a sign for you. And I'm going to talk more about our training and consultancy services as we go further. And now is it's time to learn, it's time to go into the real deal. And I'll be handing over to our dynamic facilitators, our tutors, Miss Victoria and Mr. Ridwan, who will take us through today's geospatial session, and they'll walk us through what GIS means, how DM works, and how to use QGIS to process and visualize our data. So please give them your full attention, and remember to note your questions, as we'll be having our question and answer session afterwards. So you can just drop your questions in the chat box and we'll respond to them. So please listen attentively. Thank you. Miss Victoria, are you there?
Yeah, I'm here. Good evening, everyone, and welcome once again to today's training. My name is Oludipe Victoria, and I am a GIS analyst at DigGeoNaija. So, please give me a moment to present. So today I'll be taking you through the practical introduction to geographic information systems using QGIS. So whether you are completely new to GIS or you are just starting with QGIS, this session is designed to help you to build a strong foundation in spatial thinking and digital mapping. So today we'll begin by understanding what GIS is and how it helps us to analyze and visualize spatial data in real-world application. So we are going to touch key concepts like thematic mapping, digital elevation model, which is known as DEMs, and I'll introduce you to data sources like SRTM, ASTA, and LIDA, and how they are used in terrain analysis. So from there, we'll move into the practical aspect. So by the end of this session, you would not only have an understanding of spatial data, but you also have the confidence to start using QGIS. So moving on to what is GIS. GIS simply means Geographic Information System. And this is a framework for capturing, storing, analyzing, managing, and visualizing spatial or geographic data. So it is a computer-based framework that has location tied to it. So basically, GIS helps us to make smart decisions using maps. So the main functions of GIS includes data collection, and you can collect data using GPS, satellite surveys, your mobile app. You can collect data using drones and also from field surveys also. Then another function is data storage, and GIS helps you to organize spatial and attribute data. That means data you've gotten from the field or from different location, you can store them in geographic information system in GIS. Another function is data analysis. So GIS helps us to answer spatial questions like, okay, which communities lack access to electricity, where are the most fertile farmlands, and all of that. And it also helps us in visualization. That means you can create maps and 3D models for decision making. So it turns raw data into clear map. Your data you've gotten from your field survey, you can make it into a map that once you look at it, you know that, oh, this is what this map is talking about. So it helps us in understanding spatial pattern and relationships. It is widely used in urban planning, environmental management, disaster response, transportation, and a whole lot more. So it is also important, especially in Nigeria, in agriculture, conservation, and a lot more. So there are different data types in GIS, and the two primary data is vector data and raster data, which you can see here. So one thing we should also notice is that GIS isn't just about maps. It is also about making better decisions that helps us to improve our life. So in Nigeria, GIS helps us to locate like the best areas for agriculture, like I said before. And as future leaders and professionals, it helps us to understand different sectors of the economy and for city planning and environmental protection also. So let's move on to what is vector data. So vector data represents real world features using three geometric shapes, which are points, lines, and polygons. So you can think of it as like drawing the world using dots, using lines, and then shapes. So point data basically shows a single location. It shows spatial data using coordinates. For example, maybe the different balls in Sokoto, ATM stands in Lagos, and maybe locations of buildings. Then moving on to line data, these are linear features such as roads and rivers. And then polygonal data, it includes lakes and land parcels. So it has high spatial accuracy. It is ideal for representing discrete features with exact boundaries, and their attributes are stored in a linked table, which I will show you later. So there are different file formats for this vector data. We have the .shp, which is known as shapefile. It is like the most commonly used vector data. We have JSON. This is lightweight and web friendly also. It's also a vector data format. Then we have KML, which is used by Google Earth. Oh, sorry. Okay. Which is used by Google Earth. Then we have .gpkg, that's GeoPackage, and this is also modern, and it is a type of vector data format. So it helps us in marking locations most times. So let's go to raster data. So raster data represents the Earth surface using a grid of cells or pixels, where each pixel holds a value that represents a specific attributes, like let's say elevation, temperature, or vegetation. So each pixel has a specific size known as resolution, and it contains a value. This is an example of raster data. This is a digital elevation model which shows like the terrain of this particular state. So if we zoom into this image very well, we will see pixels just like a chessboard, boxes. So each of those boxes have a value that represents something, whether it is temperature of that particular place, elevation, or it could be a satellite image or a land cover. So these are the characteristics of raster data. They are ideal for continuous data. Their resolution affects details, and the higher the resolution, the more detail and larger file size. And they represent several categories or continuous measurements. So the common raster file formats includes GeoTIFF, which is popularly known. We have JPEG, IMG, and NetCDF, which is also used in climate science. So Unlike vector data that uses points, lines, and polygon, raster data is like a giant spreadsheet, just like your Excel spreadsheet, where each cell represents a location, or where it represents a continuous data, rather, like elevation or temperature. So let's move on to basic GIS analysis that can be done in QGIS. We have, for vector analysis, you can clip, you can perform union analysis, which is a very useful analysis. You can merge multiple layers, you can intersect, and you can also dissolve. I'm going to show you how to do some of this analysis in QGIS. For raster data, you can perform aspect analysis, slope analysis, hue shade, you can reclassify, and you can also extract by mask. So let's go to thematic maps. What are thematic maps? These are maps that are specifically designed to emphasize a particular theme or subject area. So it is a type of map that, instead of showing everything like the way your Google map is, it focuses on one topic, just like the population of Nigeria, or the rainfall pattern in Nigeria. So it is built to answer one main question. For example, where is vegetation most healthy in Nigeria, like I said before. So these maps are used to visualize spatial distribution and relationships of specific phenomena. So let's move on to the next slide. Digital elevation models. What is a DEM? A DEM is a digital representation of the Earth's surface elevation. So it shows how the land rises and how it falls. It basically shows the landforms in Nigeria. Let's use landforms. Like, the Earth's surface is not flat. There are some areas that are high and some areas are low. So a digital elevation model shows the elevation distribution across a particular place. So there are different types of DEM. We have the digital surface model, which is DSM. And this type of DEM includes buildings and vegetation. And then we have DTM, which is digital terrain models, which consists of just the Earth surface without any natural or anthropogenic objects. Okay, without any natural or anthropogenic objects. So this is an example of DSM, where we can see some buildings around here, while this is a DTM, which only shows the terrain of a particular place. So we have different sources of DEMs, which are SRTM, ASTER, and LIDAR, and they are also different in their own ways. For example, the SRTM, which means Shuttle Radar Topographic Mission, this is collected by NASA using radar on the space shuttle Endeavour. And what this does is that it sends radar signals to the Earth's surface, and it measures how long it takes to for the signal to return back. So it has a resolution of 30 meters, and there are also 90-meter resolution also, and the accuracy is moderate. It has a global coverage in large-scale studies, hydrology, and environmental modeling. So the difference between this and LIDAR is that that's a lower resolution compared to LIDAR. And the common sources of SRTM data is NASA and USGS. So we also have ASTER data, which is Advanced Spaceborne Thermal Emission and Reflection Radiometer. So this is also collected by NASA and Japan METI on board. So what this does is that it uses visible and infrared lights to measure elevation across the Earth's surface. The resolution is 30 meters also, and it has moderate accuracy. The coverage is also global. So it has application in remote sensing, earth sciences, including elevation, and it has better resolution in some areas than SRTM data. And common sources are NASA and Japan medicine. Then for LIDAR, this is light detection and ranging. This is collected by aircrafts, drones, or satellites. So how this works is that it shoots laser pulses at the ground and measures how long it takes for it to bounce back. So the resolution is extremely high, is 1 meter or even lower than that. It has local to regional coverage, and it is limited by cost and availability. It's not available in Nigeria yet. It is also, it has application in 3D terrain modeling, forestry, and infrastructure. So the common sources are airborne LIDAR, satellite LIDAR also. So let's go to the applications of what we're doing here today, the application of GIS and elevation studies. So we have number one, geological and geophysical studies. If you are a geology student or a geophysical student, you can use it to map rock formations, fault lines, and mineral resources. You can also use it to identify areas that are prone to geohazards, such as landslides, earthquake, and volcanic eruptions. Like this map was done using QGIS, and you can also do something like this on your own. So another application is in land use and environmental monitoring. So you can decide to use GIS to access deforestation, desertification, and urban expansion in any state of your choice. You can decide to track biodiversity and protected areas for conservation efforts. So this is a land use land cover map, and from the legend here, you can see that this place, this is Africa, this is Cameroon in Africa. So we have the areas where volcanoes happen, which are these dot points here, and this is a land use land cover, which can be further interpreted. So another application is in hydrology and water resource mapping. You can decide to map river basins, watershed boundaries, and flood prone areas, and then you can decide to monitor groundwater level and water pollution. So this is another map also, this is the SRTM map and the hillshade map, the terrain map of this particular place. And we're going to show you how to do this type of map in this session. Then another application is in climate and weather analysis, whereby you can display temperature variation in different areas. And you can also create a map of rainfall distribution, let's say in Lagos State, and you can also map areas of extreme weather events. So this can be used to understand different climate change in different regions. You can even decide to use it to work in areas that are outside of Nigeria, like you can see in some of these maps. So I'm going to take you through a little bit of the introduction to QGIS and show you some live demonstration. So if you've installed your software and you've opened it, this is how it should look like. So QGIS is also known as Quantum GIS. It is a free and open source GIS software. So you can use it to visualize, analyze, you can use it to edit spatial data on both raster and vector formats. So it also has different plugins that you can use, just like having your phone and then installing different apps in it that you can make your phone to function better. So you can also do that in QGIS here. So I'm going to show you how to import the data into this software. Let's say you want to get the map of Nigeria. Okay, let me first show you, put you through some of the interface. So this is the this is your map Canva. This is where if you import your map, you can easily visualize it. This is the layer panel here, whereby when you import any map into your software, it's going to dock itself here, and you can visualize it here, and also check out the properties here also. Then this is your menu bar also, where you find your project. You can decide to create a new project, you can open recent projects, you can save projects, and you can also exit the software. You can edit here, view, layer. You can also go through it, explore your software. If you want to perform any vector analysis, you come to vector, and then you can check out the different analysis that you can perform here. Then for raster analysis also, you should be able to use some of these extensions here. Then database also, HCM, GIS, processing, and all of that. Here you can come here to install some plugins, like some additional extensional tools that you can use in QGIS. So there are some shortcuts over here also, where you can easily like open a new project, save your work, zoom in and zoom out, and different other extensions. So let me take you through how to import to download a data, the map of Nigeria, and how to edit some of it. So first you come to this HCM GIS plugin. If you don't have it here, you go to plugins, manage and install plugins. Once you click that, it's going to search it. A pop-up window will show. Okay. So this is it. So you come here, you make sure it is on this all, and then you type HCM GIS. So since mine is installed, I don't need to install it again. But for yours, you can just select it and then come here to install here. So once you install it, you just close this tab. Then it's going to appear here. So once you come here, you can download open data from this HCM GIS plugin. So you go to download open data, and then global administrative areas by country from GADM. So here you can select different countries. You can select the country you want to work on. So you can just look for Nigeria. This is it. It has 3 levels of details. That's the state, the local government, and the boundary. Then you can apply. Because sometimes it takes a while to download, and if you already have maybe the vector file on your system, you can just import it. So but if you don't have it, you can just decide to apply, and it's going to download. But since I already have mine and I want to import it into the software, I'll go to layer, add layer, then add vector layer. So you come to these 3 horizontal buttons here to browse to your file where it is stored. Then you select it. You can just select. Remember I said that the vector file can come in .shp format. So you select the GADM 1, 0, and 2. Open, then add. So if you decide to download it from here, it's going to appear in your layer panel. So this is the level of detail 2, which shows the different states in Nigeria. If I uncheck that, I can see the layer beneath it. This is the one that shows the different states in Nigeria, and then this one just shows the boundary. So we can also decide to check, okay, what kind of attributes do these data have? So you can right click on it and then open attribute table. So once your attribute table is open, you can see the different features of the data you have, the different states we have in Nigeria down to Zamfara, and then you can look at other features also. If you open for this GADM2, open attribute table, we can see the different local governments we have in Abia State, Aba North, and all of that. We can decide to go down to Gombe and see the different local governments in Gombe State and the area each of these places cover. So we can decide to also view the different states here by double clicking this, because looking at this data now, we can't really interpret anything from it. So when you double click, you go to label, then here you select single label. Then you make sure the value is ABC name 1, then you click OK. So once you do that, we can see that another layer has been added. We can see the different states that are in Nigeria, Kogi, Benue, Taraba, and all of that. So you can also decide to visualize this, like maybe you don't want brown color, you want a different color. You double click on your layer. Once you do that, you go to symbology. Then if you don't want this brown, you can come down here and then click this green and click OK. And also you can decide to change it again, that different states should have different colors. So instead of single symbol, you can click categorized, then the value, we'll use ABC name 1, and then we'll classify. So now here we can see that the different states have different colors attached to them. So when you click OK, you see that different states have their own color assigned to it. So now if you want to focus on a particular state, let's say you want to work on Zamfara State now, you can decide to just, and you want to extract only Zamfara State from this whole map. You make sure that this place is highlighted as you're showing blue here. Then you come to this select feature by area tool. Once you select it, your cursor is going to change. Remember, the cursor was this palm, but once you click this, the color is going to change. Then you can select a particular state. Once you select it, it's going to be highlighted. Then let me do that again. You make sure that this place is highlighted. You'll come to this select feature by area and then select the states you want to work on. If you Sokoto, once you select it, it's going to be highlighted. Now, what you do is you right click on that same layer. You go to export and save selected feature as Sokoto. And click enter. Once that is done, you can uncheck this whole map of Nigeria, and then you see only the states that you want to work on. Let's do that again. Let's say you want to work on Zamfara. You make sure that your select feature by area tool is on, then you select Zamfara. You right click on that same layer, go to export, save selected feature as, then you type your states and click enter. So now we can see that Zamfara State is on its own now. So if you want to perform any analysis that is based on this state alone, you can do it instead of working on the whole of Nigeria. Now, another thing we can do is that, let's say we were given only the shapefile of Sokoto and Zamfara, and we want to merge the two states together so we can work on them together. We can go to this vector tool, go to data management tools and merge vector layers. So we come to this input layers here and select these 3 horizontal dots. Then we'll select Sokoto and Zamfara and click OK. Then you can click run. So once that is done, we'll have it as a merged layer. If I uncheck this one, you see that it's already joined together. To zoom this in, you can right click and then click zoom to layer so you can visualize it very well. So if you were also given your shapefile like this, and then let's right click on this and click show labels. This is Sokoto, this is Zamfara, and they tell you that okay, you should extract Zamfara, like separate Zamfara from Sokoto, since it's only Zamfara we want to work on. You can go to vector, go to geoprocessing tools and clip. So your input layer will be your merged layer, or it could be any name you decide to name it. And then your overlay layer will be Zamfara or Sokoto, and then click run. So once that is done, if you uncheck this merge layer, you see only the layer that you clipped out. And if it's a Sokoto you wanted, you can put Sokoto as your overlay layer so that Sokoto will be separated from it. I hope we've all gotten it to that point. This Ridwan is going to take it from here. Thank you so much.
Thank you. Thank you for that wonderful session. I hope you can all hear me. Please kindly confirm if you can hear me. Okay. So I'm sorry, I'm about to switch my screen. So I would be sharing my screen now, and I would like us to confirm if we can see my screen. If you can see my screen, just use a thumb up and signify that you can see my screen, please. Just share a thumbs up. Thank you. So my name is Ridwan Osele, and I'll be taking it from where Ms. Victoria stopped. So just like she's a vector layer, and I will be selecting states in Nigeria to work on, and I'll be putting us through how to manipulate raster data or our vector data, and so how to perform terrain analysis with QGIS analysis with QGIS. So performing terrain analysis with QGIS involve creating layers like slope, hillshade, and aspects and other terrain map to see certain features that can be hidden from this layer when we don't visualize it properly. So we usually use terrain analysis to show some hidden features that can't be easily seen unless you analysis. So one of the some of the features we'll be using today include the raster tool and maybe a little bit of the vector tool. So I have my raster layer here, the one Miss Oludepa showed us earlier, and I also have my vector layer here. So I'll start by extracting a state of choice in Nigeria. Then I will also put us through how to clip our data to these states, and I would show us how to perform some of the terrain analysis. Then I'll put us through how to export the maps in any format you want, either JPEG or PDF. Please kindly confirm if you can still hear me. Thank you. So to start, we'll follow the same process and show the same process methodology show us. So you click on the layer you want to extract from. So I'll be selecting a set of choice, let's say Oyo State. So to extract, I will start by right clicking on the state. So after right clicking, I will scroll down and select Open Attribute Table. So once I select Open Attribute Table, I see all the information that are in my layer. So this includes the name and other information. So I select open attribute table and I click on Oyo State. So after clicking on Oyo State, I can close this and Oyo State will be highlighted from um, my data. So I can right click again, and this time around I'll go down to export. So under export, I have different options. So I can select save selected feature. So selected feature as I input the name of the layer I want to save, which is Oyo State, and I can select OK. So once I do this, Oyo State will be separated, like Victoria said earlier, and I can uncheck this layer and deselect. So let me zoom to Oyo State. So after looking at Oyo State, I want to use this boundary to limit my data, which is the Nigerian data here. So this data is not all I need. So I just want to extract the part that belongs to Oyo State from it. So what do? I come up here to my menu bar. So the menu toolbar here, I click on raster. So under raster, we have different options to use. So I'll come down to extraction here. Under extraction, we also have two different options to extract. So we have the clip raster by extent and also have the clip raster by mask layer. So I'm using the mask layer, which is the shape file I just extracted. So I'll be clicking on clip raster by mask layer. So once I click on this, a pop-up will appear and I can see my input layer is already the raster layer that I want to extract from. So I'll be inputting the shape file I extracted for my mask layer. This is to limit the bigger data to the boundaries of this smaller data. So if you want, you can select a CRS, which is the coordinate reference system for my layer, to position my data properly with the right coordinates. So I can tell the software, okay, this is my source CRS, and I also want it to be the target CRS. So you can also set the target extent also to the same layer that we use to ensure accuracy, to pick the right points for the maximum extent. So under here, you will assign the no data value, which is telling the software that any data with this value, don't count it as part of my data. So at times we say minus 999 and something. Sometimes we say 0. So here I'll be using 0 and I'll click on enter. So after this, there are also other options to tick here where we have the match the extent of the clip raster to the extent of the mask layer, which is checked already. I can also click on keep resolution of the input raster to tell the software that I want the same resolution for my data. So once I'm done with this, you can save and don't do like me. I'm not going to save, but you can save by clicking on these three dots here and save to a file of your choice. So I'll be clicking on run. So the software will begin the process, and this will be done within some seconds. So once this is done, I can close this and we can see that there is a separation, like a difference in the bigger layer and a smaller layer here. So I'll uncheck the bigger layer and zoom to extent by right clicking here and clicking on zoom to layers over here. So we can see the DEM data that we extracted. It has been limited to the boundaries of Oyo State. So this is my raster layer here, and it contains certain information about the elevation of Oyo State. So please kindly ensure you can still hear me, please. This is to make sure I'm not disconnected from the class. Okay, thank you. So this layer contains certain information about the elevation of Oyo State, and we can't see it properly now, but just to give us a brief from the label here, from the legend here, we have a minimum of 60 and we have a maximum of 569, which is telling us that the maximum elevation we will see in this region is around 569 meters high above sea level. So to see this properly and to see what this layer is talking about, we will have to style it. So in order to style it, you can decide to double click on your layer. You can also right click on the layer too. Once you right click on the layer, you can select properties down here. And once you select properties, it gives us all the properties of this layer we are discussing about. So currently, the layer is set to single band gray, and that is why we have a monopolized monopolize appearance of the data. So we have to change the render type to single band pseudo color. So once I change it to single band pseudo color, I can select a color of my choice, which is I'll be using 2 here. So to show us that the maximum data should be red and the minimum data should be blue. So I'll click on apply and then select OK. So when we look at this data now, we can see that the higher elevations in Oyo State are towards the north and they are displayed in red, and the lower elevations are towards the south and they are displayed in blue. So this is to give us the idea of the certain type of elevation that we have within this region. So this same data I extracted can be used for our terrain analysis. So how do we go about that? I will start by showing us how to create an hillshade layer, which is actually a 3D representation of how the sun interacts with the terrain. So how if we tell someone that the sun is interacting with the terrain, how do we tell this person how do we show it to them that this is the effect? So the hillshade will help us to visualize this properly, to show us that this is what is happening. These are the high elevation, these are the valleys, these are the mountainous region, these are the hilly regions within this data. So to do this, I'll come to raster again. And since we are dealing with raster layer for now, most of our tools will be under raster. And if we are dealing with the vector, most of our tools will be under vector. So for now, we'll be under raster. And if I want to convert a layer to a certain projection, maybe I want it to be exactly on meters. I want the unit to be exactly on meters. I can reproject it first by coming to projections. Then I'll come to WAP reproject here. So I want this layer to have a unit that is in meters, because currently my unit is in degrees. So I'll tell the software that this is my source projection, which is in called geographic. So I'll sorry for that. Can you still hear me, please? Please, can you still hear me? Thank you. So you can decide not to set a no data value, and you can also decide to tell the software your preferred resolution from here, but I won't be telling the software to use the resolution for now because I'm not performing a certain deep analysis. So I can just tell it to run like that. So once I run, it will give me the resulting layer with its CRS in projected, which means that certain the certain value. Over here, we see the maximum as 560. Means this is representative, showing us that yes, this layer is actually in meters. So this is a way So I will start by creating the shade layer. To do this, I will come to raster again and I'll select analysis. So under analysis, the aspect of the hillshade, we have the slope. We also have the terrain ruggedness index. So I'll be making use of the hillshade alone. So I'll click on hillshade, and under hillshade, we should be I already explained what hillshade is to us. So we can input our raster layer as the input layer, and we have an exaggeration factor here, which is the Z factor, to ensure correction based on the CRS we use. If I was to use the reprojected, I'll leave it at 1 to use the same units. But since I'm not using the reprojected and I'm using the geographic, I have to correct for correction Z factor to 0.0004, which is to ensure accuracy based on what we just saw here, the difference at the so we leave the scale at 1, and the azimuth of light is the direction of the light from the top of the earth the position of the sun. So we are saying the direction of the light, we are leaving it at 315 degrees, and we are leaving the altitude of the light also at 45 degrees. So we can tell the software to compute the edges and also run it that way. So once you run it, the software will process our A-shade layer. And let me close this and uncheck this. So this is what our A-shade layer will look like at first before we further process it to see better information. So how do we process this? We also do this by double clicking on the layer again, which is the A-shade layer. We double click on this. Once you double click, you can change the render type if you want, but we leave it as single band gray. Then the brightness, we have certain values we use for correction here. So we set our brightness at 85 and we set the gamma at 2. So set the contrast at 35 and we set the grayscale to be by lightness. So after this, we also smoothen it using bilinear, both the zoom in and zoom out. This is to give us a smoother layer as our output. So we apply. Once we apply, let's see what we have here. This is a better view of our shade, and if we zoom in, we can see that we have a kind of basin here, or a lowland elevation water body here, which can be identified if we are to show it on our Google map. And we also have the higher elevations here showing us some of the fault lines, in fact, but we can't see it better until we use further tools. But these are just some of the things we can see from our A-shade layer. And we can also overlay our DEM data on our A-shade to see the comparison or the similarities between both of the data to see how they correlate, how the high elevations and the low elevations correlate. To do this, I will arrange my layers in such a way that my SRTM will be at top of my A-shade. Then I will check my SRTM. So once I check my SRTM, I will have to edit my SRTM to show me some of the things that are underneath it. So how do I do this? I come to the SRTM and double click. You can also right click and come to the properties. Either way, you still get the same result. So once I do this, I change the blending mode to multiply. Then I apply and then select OK. So once I multiply, we can see that there is a difference in how the layer appears now. We can see that the high elevations are correlating with the rugged part of the terrain, while the low elevations are correlating with the smoother part of the terrain. So this is a way to show us how we can perform simple terrain analysis with QGIS. So another terrain analysis is the slope. We can also create our slope. We can also create aspects. Slope is actually used for inclination, to see our inclination, how this terrain is inclined, um, how it is how it is inclined actually with slope. And we also have aspect to show us direction, how the which position is this terrain facing. We want to know which part are exposed more to the sun. We want to know which parts will be more darkened throughout the day, which parts will have lesser sun exposure. We also have the terrain ruggedness index, which can also be used to extract some of our faults. And we use this also to know the more calmer part of the terrain and the rugged part of the terrain, among others. So these are some of the terrain analysis tools that we use, and this is just a simple terrain analysis. So after having our results here, what do we do? How do we bring it out? How do we show that yes, this is my layer, this is what I did? So to do this, we create a map layout. How do we do this? I'll come up here to my project, the menu bar here, and I'll select projects. Then I'll create a new print layout. So once I create a new print layout, it will ask me, the software will ask me for a title. So let me confirm if you can still hear me, please. Kindly use your thumbs up, please. Thank you. So I will set in my title. Okay, So what is this new interface telling me about? This is a whole different section. Yeah, it's like an extension. We will edit whatever we've done with our Canva. So we have multiple tools. The menu bar, like we have the tools that we use that for exports, these are for duplication. And we also have another bar. We also have for that just because of our shape and edits. I mean, start panel here, which is like our toolbar, and the apps of them like panning to zooming to the selection to the moving to and some others. So this tool will be so I'm clicking on this tool and come to add item, click on add. I will use this. So you have the is on your screen and the map rendered on our screen. So this what we have and automatically on the key. So once we have this, can edit so through to frame first. I'll click on first, send the grid, add the grid, then click on grid, modify the grid. I'll be data to use to the my boundary or so let me say I'm setting my phone. So is grid
everyone. So I'll continue from where it stopped. So what it was saying was that your map is not complete if you only just analyze it here and leave it here. You have to export it in a way whereby you can have it as an image, where you can put in a research publication, or you can send it to a friend to check it out for you. So how will you do this? You go to project and go to new print layout. So this pop-up window will show, and then you can decide to name it map of Nigeria and click enter. So once you do that, a new pop-up window will show, and this is where you can perform your print analysis. So what you do is you come to add item, then go to add map. Once you do that, this plus cursor will show. Then you can decide to draw it. You make sure your cursor is clicked and then draw it over the Canva. You can see that the map has rendered here. So if you don't like the position of the map, you want to adjust it, you can decide to come to this move item contents, because if you use this one, it's going to shift the whole map. You can see it's already out of the main Canva. So you come to this move item contents here, and then you can move the map alone. So I can decide to just put it here. So now we can decide to grid our map. You come to this place. This is where you can grid your map. You scroll down. You can decide to add frame all over the map. And you can change the color of the frame from black to any other color, but we can leave it as black. Then to add grids to our map, you come to this grid icon here. Click on plus and then modify grid. So for your X, we can use 1. Okay, that's too much grid. Let's use 5 or 3. Okay, that's fine. We can use 3 for X and Y. After doing that, we'll go to draw coordinates. So we can see now that we have coordinates all over our map. Then instead of it being outside, we can decide to put it inside the frame for the left, right, for the top and bottom. So put all the coordinates inside the frame. So once that is done, you go back and then come up and lock your layers. So once that is done, you lock it here, both up and down, and then lock it here also, so that if you want to even shift your map, it won't be able to move. So we can decide to add scale to our map. This comes to add scale bar, and then you draw that also. So we can see that scale has been added to our map, and then we'll lock it here also. Because if we don't, it can be easily moved when you're trying to move something else. So you can also add your north arrow. You know, most your map is not complete without your north arrow. So any item you want to add, you just come to this left part of your toolbox. So this is add north arrow here. You click on it, and then you can draw it here. So if you don't like this north arrow that is just like this, you can decide to change it here at this bottom right part of your screen. All right. Okay. So you scroll down, you can select this one or any other one you like. You can also use this one also. And then you can change the color. When you scroll down, you can choose black as your fill color or any color of your choice, gray. And then you lock it also. Remember to always lock each and every item you add to your map layout. You can then decide to add legend to your map. So you draw legend here or any space of your choice. So for your title, you can just title it as legend or any title of your choice. Then if you want every item in this your layer panel here to be added to your map, you can leave it as auto update. But if you want only what is depicted on your map to show, you can uncheck this auto update and then remove the ones that are unnecessary. These ones now, they are unnecessary, so I'll just remove them. So this one, I'll just drag it up. And it's a lot of items here. So what you can do is you come to this column here, and then this count, instead of 1 for it to be 1, you can decide to change it to 5. Then click equal width and split layers. So like that, your legend has changed. But there are still some things we have to remove, like this two. So you just click minus and remove those ones. So let's change this to 4. Let's try and find a way to fit this in. Or we can just use only this map instead of this one. So I'll come to my map here and then uncheck this. Once I uncheck that, the map that is displayed here, that's what's going to show here. So I'll lock each of the layers and then lock it up here also. So like that, I can change the legend. If I want to edit any item, I'll check it here or click on it. Then I'll just remove this one. So it's just going to remain this one here. And I can change the name. I'll double check it. Her name is Map of Nigeria. So once that is done, I'll just lock it here and you can add frame to make it, to beautify it. So you can also add a title to this layout, and then you come to, how will you do that? You come to add item and go to add label. So when you go to add label, you draw the extent you want it to, or where you want it to be. Then come to this bottom right and name it map of Nigeria. This is very small. We can increase the font size. So let's use 50. You can decide to add frame to that, and so you can just lock that also. Let's remove the frame so it doesn't look weird. Now that this is done, we can decide to export this as an image. So we'll come to this export as image, and you can also export it as an SVG file or export it as a PDF. So I'll click on export as image, and then you can decide to put it in any file, name it as map of Nigeria. Your save type can be JPEG, or you can choose any format that you like. But let's leave it as JPEG. Then we click save. For our export resolution, we can use 750 dpi. We have to save it as a very high resolution map, and then you click save. So this might take a while to. Okay, that is done. So you go to where you saved it and check that. So this is what we have at the end of the day. So you can decide to make your own map better. You can decide to do the raster analysis that Ridwan was taking us through, show your terrain, the hillshade and the SRTM, and then make a print layout, and then you can share it with your friends, share it on LinkedIn that okay, this is what you've done, this is what you learned. So I hope we were able to get something. Thank you so much.
Thank you so much, Ms. Victoria and Mr. Ridwan. I'm sure we've all learned one or two. So now it's time for our question and answer. And I would go through the chat box and see if anyone has questions to ask. Oh, Didi asked if the call is recorded for those who joined late. Yeah, subscribe to our YouTube channel and turn on notifications. Turn on your notification and so that you will know when the video drops. I hope Kingdom now understand the raster data because Miss Victoria went through it again, I guess. The name of the software is QGIS. For Kingdom Obina, yes, the name of the software is QGIS, and an installation guide was sent to everyone with their event details, so you'll be able to navigate through that. Do we have any other questions? You can raise your hand if you have any other questions. Okay. Miss Daniel, please make it easy to download on the. Once it drops, you are going to see it. You can always go back to it to watch. Just make sure you are subscribed to our YouTube channel. So I think we can move on to the next. Sorry. I hope we can all see my screen. Okay, so before we round off, I would like to share this. When we started the program, I was saying something about training and in DigGeoNaija. So here is one. We offer geospatial analysis and also data analytics programs, and even DUAP. Yes, just like this, just like today's workshop. We can start with, let me start with DUAP. You can join the movement in few powerful ways. If you are ever elected as a course rep or a departmental executive or even a faculty president or SCG president, and you are thinking of how to give back to your department, to your school when elected into this role, this is one powerful way. You can use DUAP as your legacy project. Imagine leaving your mark through something that benefits the whole department or the whole school. And if you know any alumni, tell them about DUAP. It is a great gift idea to give back to the department, to the schools. You can even imagine donating a digital map, a workshop, instead of just a random thing. So DUAP is the perfect gift. And for our geospatial skills, if today's I'm sure today's workshop has actually sparked interest in learning more about geospatial skills. We have one coming up. Our core 2 is happening from August 4th to August 16th, and it is fully online. You will learn tools like QGIS, Google Earth Engine, Google Maps, and you'll be able to work on real world projects and walk away with solid skills to help you grow your career. And there's also a 25% early bird discount if you register before August 3rd. So if you're serious about building your confidence with location data, don't miss this opportunity. So thank you all once again for being part of today's DUAP session. We hope it inspires you to explore the geospatial world. And remember that the world is mapped and there's still so much to discover, and you have a role in shaping that future. So follow DigGeoNaija for more updates, for more trainings and upcoming events. Until next time, keep exploring. Thank you. Have a wonderful evening.